For my final project, Max Anhalt and I designed a 1 bit per stage ADC that cascades over 8 stages to create 8 bits. This image shows the general outline of how each individual stage goes. So it takes an analog input that gets run through an A to D made of comparators, which then takes the output bit. The signal is run through a 1-bit D to A into a summing junction with a gain stage of 2 afterwards. This compares the resolved bit back with its analog original value before it's passed along to a next stage. And then the drawing below shows the cascade of stages. This only shows 4, but our design has 8 bits in it. And then not shown in this picture, there's also a sample and hold on the analog input, just because we were having timing issues. So that made it so that each stage could hold on to the value it was measuring. This is a look into the 1-bit D to A and the summing junction and the gain stage. So the D to A was implemented as an inverter going into 2 transmission gates from a VREF plus and a VREF minus. So this would output a VDD or VSS depending on what the input signal saw, or what the input signal was. This is then run into a difference amplifier with a gain of -2, which allows for the removal of the ×2 gain stage, since it's already embedded within the summing junction. So this was the cadence schematic of what I just showed. It's the DAC running into difference amplifier, which is I poorly named this comparator V2 when I was changing up the file. Originally, I never changed the name, and then I never got around to fixing it later. This is a full stage schematic. It's got an input going into the sample and hold, which gets run into the comparator A to D, with the signal then run into a DAC, which goes into the difference amplifier. This is the same as the one seen up here. And then the output, instead of running through a 1 megohm resistor, will be run into an identical stage. And then the output is taken here at comp out. It's not shown here, but that's where each bit is measured or read. And this is a simulation of that above schematic. Comparing it with a sinusoid, these jitter lines occur on clock edges. And as you can see, it roughly follows the overall shape of a sinusoid if you ignore the jitters, which don't have any impact on the performance. So next, I'll show a full cascade of the system. So these are the 8 bits, each with a bit out. Then the results of that, we input the analog or the binary equivalent of, we input the analog equivalent of 0, 1, 0, 1, 0, 0, 1, 0. As you can see here, what we measured out on each bit stage was a 0, 1, 0, 0, 1, 0, 1, 0, which is close but not exact. We couldn't get it any closer than this due to project timing constraints, and then overall performance of the circuit. We had to make some compromises due to the complexity. Originally, the design idea was to have the whole system integrated into one, or each stage integrated into one component, and we ended up thinking that would be too much to work off of. Since Tina went over ADCs pretty thoroughly in lecture, I thought I would talk about some things I learned about layout over the course of this project. So up here in the top left, there's this button here, which is full select versus part select. Right now it's set to full select. So if I go to one of these metal 1 rectangles and I try to select part of it, it won't work. But if I select the whole thing, now there's one component selected. But then if I set it to partial select, I can highlight a part of it and it'll select just the edge. See how it's white now? Just the edge that I wanted to look at. So if I wanted to stretch the part, for example, I would just press S, and now that edge is already selected. The next thing I wanted to show was the Align tool. So if I wanted to add a rectangle of metal 3 here, and then I wanted to align it so that the left edge of the metal 3 rectangle lined up with the right edge here, and then the bottoms lined up, instead of trying to place it by hand manually, there is this button up here, the Align tool. So using this, you start by setting a reference, which in this case I'm going to pick to be this. So right now it's set to the bottom, but I'll show, I can show this first, I guess. Then after the reference is set, I would select this component. Then I would hit apply, and now they're lined up along that axis. If I want to change that, I'll go vertical. I'll select right edge. Here, left edge pre-selected. I click on the component again, I hit apply, and now the pieces are lined up.